Translation. A translation moves an object from one place to another. Every point on the object moves the same distance in the same direction. When describing translation, it's necessary to give the translation vector. Translation vector is a column vector like this. A represents the movement horizontally, x direction. B represents the movement vertically, y direction. Under a translation, each point is moved a fixed distance in a given direction. Suppose the point P must be translated 5 units in the x direction and 3 units in x direction. Look at the diagram. Let's represent the point P, or position vector P. We can get the image of point P writing image of point P, or new coordinates, equals coordinates of point P, or original coordinates, plus translation vector. We must add 5 units in x direction and 3 units in y direction. This is the image of point P. Look at the diagram. Let's see how it works with a plane shape. Example: the triangle ABC is drawn in diagram. Translate the triangle by the translation vector. Look at the diagram. Let's draw the triangle ABC. This is the matrix representing the coordinates of the triangle ABC. We want to convert the triangle 4 units to the right and 5 units to the top. In other words, we need to add 4 to all x values to move the triangle to the right and 5 to all y values to move the triangle up. Since we will not translate a point that has one ordered pair, but a flat shape with more than one ordered pair, we will need a translation matrix and not a translation vector. The translation matrix will be the same size as the matrix representing the coordinates of the flat shape, and the columns will be the translation vector. This is because we only add matrices that are the same size. So the matrix translation will have 3 columns. We can get the image of triangle ABC by adding a translation matrix to the matrix that represents the coordinates of triangle ABC. The resulting matrix has the image coordinates of triangle ABC.